Today somewhere, so.
Oh, I see. Because it's on the curve, right?
Olivia's here, but not in here. Samantha, there she is. All right, good morning. If you guys forgot about turning in the 70, 71, and 72 into Google Classroom, you need to do that right now. If that's not in the next few minutes, it will be considered late. So I'd ask you to do that for homework. So those should already be in, if possible. All right, today we're going to talk about how you're supposed to know if a particle or something is speeding up versus slowing down, something that they ask us on the AP exam. Then one of the packets you picked up has like 4 FRQs to it, and I printed off the scoring guide to it because I think there's value in that. I share those quite a bit. We're going to do one of those today, even though there's 4 of them there. That's 74. We'll work on more of it later on, but again, I know the snow day kind of threw an extra little hurdle at us, but this little unit, the 5.1 through 5.4 stuff, is definitely the biggest hurdle as far as amount of new content thrown at you in this section. So those FRQs can help quite a bit, I believe. Then I'll ask you to turn in the notes, and then we'll finish up class by working on a circuit on definite intervals. Kind of similar to the one you did last time, but it was indefinite and these are definite. So moving closer to the type of questions you should see on the AP exam. But first, Luna, did you win some attendance thing today?
Yeah, I got a Sonic gift card.
Yeah. Well, weren't you like not here last week?
Yeah.
Okay. Okay, so this one's real short and sweet, but this is important. This is one of those things that just randomly pops up on FRQs once in a while. In fact, that pack of 4 FRQs, if you read through all of them, you'll see where they ask this to be used on one of them. It's not going to be the one we look at today, but it is information that we'll need to apply the rest of the year. Okay, so we've already talked about the difference between speed and velocity. Speed is the absolute value of velocity. So velocity can be positive or negative. If it's positive, that implies it's going right or up, depending on the context of the question. If it's negative, it's going left or down. But for an object to increase in speed, let's come back to this one after we do these couple of examples, after I kind of summarize it. But speed and velocity, this is one of, to me, this is kind of like a physics topic, so I know some of you know this really well, but it's one of those things they do expect you to know for the AP exam too. All right, so if you have I just have all 4 possibilities here. If you have a positive velocity, you need to know that means it's going to the right or up. I'm just going to talk horizontally this time. And if you have a positive acceleration, the rate of change towards the right is increasing. So this is speeding up. If you're traveling to the right and the rate of change of your velocity is positive, then you're increasing, you're speeding up your speed to the right. If you're going to the left, if your velocity is negative, but your acceleration is positive, this means you're slowing down because you're traveling to the left, but your rate of change is increasing in the right direction. If this is positive, you're going to the right. If this is negative, this means that the rate of change is slow, or it's increasing in the negative direction, which is the same thing as slowing down in the right direction. And the last possibility is if your velocity is negative, that means it's going left or right. It's going left. If your acceleration is negative, it is increasing towards the left or decreasing towards the right. So do y'all think that's speeding up or slowing down?
Speeding up.
It is speeding up. So the quick way, I don't know, to me these question 2 and 7 are basically the same thing, so you only need to fill it out once. But there's a pattern here. If you're going to the right and your rate of change is increasing to the right, you're speeding up. But also you could be going to the left and your rate of change could be increasing to the left and still be speeding up. So basically, the way you want to summarize it is if an object is increasing in speed, velocity and acceleration must have the same sign. If they're both positive, speeding up. If they're both negative, it's speeding up. One's speeding up to the right, one's speeding up to the left, but they're both speeding up. If the signs are different, they're slowing down. So that's a good way to remember. This is the one they like to ask people because this is the one that's not real intuitive. Students think that as soon as you see a negative acceleration, that means you're slowing down. It does mean you're slowing down if you're going to the right, but if you're going to the left, it's speeding up. The rate of change towards the left is increasing. So update that page and word it in any way that will help you in the future if you have to look back at it. Again, not a big deal, but one that we need to talk about so that we can occasionally practice it. Okay, next up, we're going to look at this first FRQ on this big packet. And I apologize. Again, there's 4 FRQs here, and then there's 4 scoring guides. I don't think I have the scoring guides in the right order, but I mean, it should be kind of obvious which ones go to which. But I'd like to kind of walk you through this one because what they ask of this one, this is a real FRQ from a real AP exam. So it's good for you guys to see that. But what they ask you to do in this question is pretty commonly asked in these questions. All right, so notice right here we have an acceleration graph. You have to be paying attention to this. And then, so go ahead and read the directions there and read part A. Read the directions and read part A. I just want you to kind of see what your gut would tell you. Okay, so part A should be one of the easier parts. So let me remind you that the velocity derivative is the same thing as acceleration. So the acceleration at 2, do you guys see how that's 15? That's on the graph. So that means the derivative of the velocity at 2 is 15. So does that mean that is the velocity increasing or decreasing? It's increasing, so yes. And then what would be an explanation? How do we know? Yeah.
Acceleration is positive.
Okay, so I would say acceleration at that time is positive. Acceleration is not positive all the time, so we need to just be specific. At that time, it's positive. And that's it. Acceleration is positive, so velocity is increasing. So you don't have to go back and forth here. I'm going to try to refer to the scoring guide, but of course you guys are always welcome to look at it later. On this question, they gave 1 point if you got the answer right, and you had justification that makes sense. Okay, that's not really why I want to do this one, but the reason why I want to do this one is so we can talk about B, C, and D, because we have talked about area under a curve a little bit, but we haven't really talked about any applications of it. I mean, of course, there's the applications if you're trying to build something and you need to know how much material to have, that's fine. But this area can represent quite a few different things. So first off, let's make sure that we realize that the velocity at the beginning is 55 feet per second. I think you should add that to your graph. And then this area under the curve, which is one thing that integration does, is going to help us with this as well. So let's actually calculate this area. Now, since this is not curvature stuff, we don't need integration. We can actually compute this perfectly. For example, this is a 2 by 15 rectangle, so it has an area of 30. This is a 4 by 15 triangle, so it has an area of 30. This is a 4 by 15 triangle. Well, I don't know if you want to call it negative 15 or positive 15, but this is 30. Also, because it's below the x-axis, remember that has to be negative. So if you count this 15 as a negative 15, then you don't have to worry about that, but I tend to just find the area, and then positive is above and negative is below. Again, all this area is going to mean something in a second, so just bear with me a second. Then I've got a 4 by 15 rectangle, so that would be, is that 60? Does that sound right? Okay. Below the x-axis, so that's negative area. We've got a triangle, so 1/2 base times height. Looks like this is negative 15. Negative because it's below the x-axis. And again, we care about 0 to 18, so we also need to figure out this one. This is a triangle, so base times height divided by 2. The base is 2, the height is 15, so the area of this is 15. Okay, so now let's think about what this area represents. And you did do this one time, if y'all remember, in December, we did an airplane FRQ, and you had to describe what the area meant. But if we're doing like length times width, and the width units are feet per second squared, I'm getting that from right here, and the width units are seconds, I'm getting that from this. Then when you think of length times width, it's like seconds times feet per second squared. And so these seconds cancel out one of these seconds and leave behind feet per second. Okay, well, what kind of units is feet per second? Okay, velocity is feet per second. So in this example, area represents the change in velocity. I know that the area is velocity because I'm thinking about the units, like length times width, let them reduce, gives me velocity units. And so this is how velocity is going to change. They told me velocity starts off at 55, and since this is a positive 30, I know at t equals 2, it's gone from 55 and increased by 30, so now it is 85 feet per second. Then it increases another 30 feet per second, so that would be, what, 115? It's going to be helpful if you write these things down on your graph as we go through. Then at t equals 10, we've lost 30 feet per second. So if it was 115 here, minus 30 gets us to back to 85 feet per second. Okay, and then at t equals 14, I kind of missed one thing, but that's okay. You're likely to do the same thing, so we'll just go roll with it. Okay, it looks like it has lost. Notice I subtracted here because this is negative area, so it's losing velocity. It loses another 60 feet per second from 10 to 14. So it goes from 85 feet per second to 25 feet per second. So I know the velocity at t equals 14. And then t equals 16, it loses another 15. So that would put us at 10 feet per second. And then finally, at t equals 18, it got that 15 back, so it's back to 25 feet per second. So in this case, the area under the curve represents the change in velocity. They told us the starting velocity, and at each one of these little intervals, I can keep up with how velocity is changing. So look at all those numbers, and does it look like the velocity is ever 55 feet per second? Yes? Okay. Around what time do you think that occurs?
Between 10 and 14 seconds.
Okay. If at 10 it's going 85 feet per second and at 14 it's going 25 feet per second, do you guys see that somewhere in that time it's going 55 feet per second? So this is where I was hesitating just a second. I knew the answer to this because I've had to work this one out for years. They're going to expect you to know at what time. Not 10 to 14 is not close enough. They want to know exactly what time. So if I split this up a little bit, and instead of doing one big rectangle here, I do two rectangles. This is 2 by 15, so this was losing 30. This was losing 30. So at t equals 12, do you see that we get t equals 12 seconds? Do you see that it would be 55 feet per second? That's how you're supposed to do that. Not try to reason it out in your head. We can actually calculate that. But you don't know to even do that if you don't start thinking about what the area under this curve represents. Okay, the y, this is where we need to start using a little bit more integral justification. So we had, starting off with a velocity of 55 when t equals 0. And then you don't want to have to write this out in words. So we can say the area under the curve, an integral from 0 to 12 of this function a of t, and you need a dt because the variable is t, equals 55 feet per second. So I started off with a speed of 55, and then the area under the curve from 0 to 12 basically ended up being 0. It was above for a little bit, and then once you get to t equals 12, it balanced out to be to 0. This is the most efficient way to do a justification. I'm not saying it's the only way you could get it, but by far the easiest. Okay, 1 point if you could figure out that it happened at 12 seconds, and then 1 point if your justification explains how you knew it was doing 55 feet per second at t equals 12. And again, what I wrote here is perfectly fine. This is a way to say I calculated the area from 0 to 12. And took the initial speed plus how it changed. And that's important. I'm going to phrase these a lot this way, especially the next couple weeks. The starting speed plus this integral represents how it changed over time. So, okay, look up at your figure there. It also wants to know what is the car's maximum velocity in feet per second and when does it occur? So, y'all look that over and tell me what you think. Okay, now you can tell me what you think. Okay, at t equals 6, the max velocity was 115. So notice how I said make sure that each one of these, as I was calculating this area, you see how I was updating the velocity. So then at the end, all I have to do is look at all the different velocities I have. So I can quickly see what the biggest velocity was and where it occurred. So for C, I'm going to do C down here. For my answer, I would say it was 115 feet per second, and it occurs when t equals 6. They give 1 point for this, 1 point for this. Now again, I know this type of question feels kind of uncomfortable right now because you guys haven't done this yet, but you'll do lots of these and it will become more comfortable. And I just hope that you appreciate that 2 of these points, like, all we really did was area of rectangles and triangles and added some numbers together. Like, there's not like some super complex calculus going on here. It looks way harder than it is. But there was 2 other points set up in this. So our justification, you can't just say, well, I looked at the graph and that was the fastest time. It's kind of like extreme value theorem. Extreme value theorem, you need to show, this is velocity. We need to show the endpoints, which would be at time 0. We know the velocity was 55 because they told us. I don't want to flip back and forth, so y'all need to tell me. At the other end point, what was the speed at the end? 25? Okay. So they want to see that you test the endpoints, and they want to see that you test certain critical numbers. So where it's crossing the x-axis, it could be like maximizing or minimizing. So that would be like t equals 6 and t equals 16. There's a good chance that it maximized here and then went down, or it minimized and then started going up. So at 6 and 16, what was the speed at 6? I'm sorry?
115.
115 and 16. 10. Okay, so the other 2 justification points, again, you can flip the page if you want to read it, but I'm reading it to you. They gave 1 point if you identified that t equals 6 or t equals 18. That you showed consideration for 6 and 18, which would be like the critical numbers. And they want to see that you considered and eliminated t equals 18. Now, of course, that scoring is going to change a little bit, but basically they're testing to see if you're actually checking the right things. You can't just say, I looked at my graph and it was the biggest number. Like, how do you know it's the biggest number? What numbers did you check? This is the most efficient way to do that. So, again, let's just formulate it similar to extreme value theorem like we did last semester. We tested the endpoints, we tested the critical numbers, and you will always get the justification points if you have those down. This specific one, though, wanted to see that you considered 6 and 18, you got a point, and that you eliminated 18. That 18 was not the biggest there. Okay, and then finally part D. So look up at your graph and all the stuff we added to it. Is there any time that the velocity is 0? Okay, so super easy to get the first point. I guess unless you just miscalculated something, 1 point if you can see that it's no. And then your justification, again, I would probably say something like the min is, well, the min was 10 feet per second at x equals, or not x equals, t equals 16. I guess this should be a t too. And 10 feet per second is bigger than 0 feet per second. If the slowest you ever go is 10 feet per second, then that's going to be bigger than 0 feet per second. And honestly, just to play it safe, I would probably draw an arrow to this candidates test. This is how I know 10 feet per second was the slowest. You don't have to copy it down again, but I do think just an arrow so that they have to go and look at that is not a bad idea. But 1 point for the justification, 1 point for the answer of no. So once again, we're going to see several of these, and this thinking of area under the curve and how to apply it to thing is going to be a pretty constant stuff. So we had velocity. We talked about why the area was change in velocity. So when we calculated the area, we knew how velocity was changing. Calculated more area, knew where the velocity had moved to. Calculated more area, computed where the area had gone to. Then we can figure out if it's ever 55, when's the max velocity, is it ever 0. It's pretty easy to answer questions B through D if you have all of this information. And again, this is calculus, but it's really just area of rectangles, triangles, and adding and subtracting. So the arithmetic side is pretty easy. Okay, so a lot going on there. I would love if you guys had a couple questions to this, especially if there's something that's bugging you about it, so that it goes a little bit smoother for you next time. Everybody's okay with this right now? Okay. Then let's move on to the last part. So, circuit. I need to show you two things on this one. One is I want to remind you, we took notes on this last class, but I want to remind you how to do a definite integral. So we'll do question 1 together as notes. And there's a few of these that they let you do with a calculator. If you read the directions here, just be sure that that's what they did. Okay. Anything with a double star here, I'm going to be okay with you using a calculator on. So you don't have to show your work on those. You can just come up with the answer. Okay, but question 1. So integration, again, there's lots of applications here. If this 2x represents an acceleration function, it's just like the FRQ we just looked at. We could calculate a whole lot of stuff about its velocity. This also represents the area under the curve of 2x from 4 to 5. So I don't know. This is such a basic function. You know its y-intercept is 0. You know his slope is 2. I guess if you carefully graphed it, you could calculate this by hand. You could do this rectangle plus this square or triangle, or you could just do a trapezoid. It would be fine too. But we don't need to do that, especially because some of these functions you're going to have no idea what they look like. That's not a good long-term strategy. I just want you to know that this is what we're finding. What we need to do is integrate 2x. So what can I take the derivative of to get 2x? Okay. Raise the power by 1, divide by the new power. Remember, you can put plus c here if you want to, but on definite integrals it's not needed. Look back at your notes if you don't remember why. But we have to put this. This is an important part of showing your work. You're going to lose out on some of the easiest FRQ points if you don't make a habit of this. I still have to evaluate from 4 to 5. So the first thing you do is you plug in the upper bound, get a number, then plug in the lower bound, get a number, and then do you remember what we did with these two numbers? Subtract them. Plugging in 5 basically gives us the area from 0 to 5, and then plugging in 4 gives us the area from 0 to 4. So if I only want to know the area from 4 to 5, I would take the area from 0 to 5 and subtract the area from 0 to 4. That's why it's working like that. And that's the answer. So you're still doing antiderivative, but you're having to practice dealing with those bounds. Plugging in the top one, getting a number, plugging in the bottom one, getting a number, and then subtracting those. So not hard, but it's something you have to be able to do from muscle memory. Okay, I also want to look at this one too, before you guys get going too fast on here. These that have double star, again, I'm fine with you using your calculator on these. Some of these have like absolute values. This is not one you can integrate by hand, ever. even after I show you U substitution, which you don't have to know right now. So the only way for you to do some of these are with a calculator. So the double star one should be that. So what I need you to do is in your calculator, you need to know where these buttons are. And it's not going to be hard to find, luckily. Okay, so last semester we did alpha y equals, and we used this number 3 quite a bit. Number 3 was for taking a derivative. Remember, it can take a derivative if you want to know the derivative at a specific point. Well, alpha window, instead of option 3, option 4 is for integration. Just like derivatives, it can't do, your calculator can't do every derivative. It can only derivative at a point. Your calculator can't do every integral. It can only do definite integrals. So, what was the question that we just did? What was the first one? It was 4 to 5 something.
2x.
Okay, so if you type it in, notice you have to define the variable, just like you need to put on your paper. That's the answer that we got. I expect to see your work on question 1 because that's one that you can do by hand. You have to practice these by hand. Some of these on your AP exam will be calculator allowed, some of them will be not calculator allowed. You have to practice being able to do it by hand. Okay, but for the one on the right, it is, let's see, -3 to 3. And then I think it's this. Is that what it looks like? Oh, it's the square root of it. Now it looks okay. Is it T's on that page or X's? It's T? Okay. As long as you're consistent, it doesn't matter. If you want to do X's, I don't know if you noticed that, but man, my calculator is struggling there. That's not an easy thing for it to compute. If you want to do X's, that's fine. If you want to change them to T's, alpha 4 gives you T. That's fine too. You just need to be consistent. If you're going to use X's, make sure you use X's all the way through. If you want to use T's, make sure you put T's all the way through. But same exact thing. So that was a calculator question. I don't expect you to, you don't have to write anything down there. You're not doing anything but plugging it in. So now this is what's going to happen to you on some of our tests. I hope it doesn't happen to you on some of our tests, but it happens to people on the AP exam, and it has happened to students in the past. There is some integration like this that is impossible to do by hand. Just like there's some derivatives that are impossible to do by hand. They are going to expect you to know how to use your calculator, because if it's one that you have to integrate and you physically can't do it by hand, it's going to be on the calculator part of the test or the calculator part of the AP exam. They're expecting that you just do this and be done with it. Yeah.
14 point, that mess isn't on this.
Is that
In terms of 5,
What's
4.55.
is there? Okay, I'll look at it for just a second. You don't have to read my question, please. I don't know what. It really should give you a hint there. That's in terms of pi.
this?
But you're right. So on this one, if it is in terms of pi, basically what's happened is the answer times pi looks like this as a decimal. So if you want to know what it looks like without pi multiplied in, you could divide by pi. And so this is the same as 4.5 pi. So one of the answers 4.5 pi. Yeah, and that's kind of weird. You don't really have to worry about dividing out pi. But one other thing to notice is, as good as your calculator is, this computation is the algorithm that it has to solve this. This is tough enough for it that you can see the calculator has a little bit of a rounding error. It's several decimals out, but it's a tiny bit off. It's actually just 4.5 or 4.5 pi. 4.5 pi. At least write the answer down, of course, and then number it when you get there. So there's a couple where you need to practice using your calculator. You're welcome to check the rest with your calculator, but the rest needs to have work checking your answer. So, all right, and if y'all can finish that up in class, I guess you don't have homework. But I'm going to finish grading in these last homework assignments that came in, and then I'll come around and help. So if you get really stuck.
Wait, were we supposed to trigger the circuit last time?
Yes.
Okay, can I still set that in?
For late credit, I guess. I asked you to turn it in last time. The homework was to turn it in. And when you don't take my advice, and then you don't show up on class to get the last warning, then if I just give it to you, then you're never going to adjust your behavior. So let me put in these last few grades, and then I'll come around and help. Again, this anti-differentiation, this is the exact same thing you did on the last circuit, except you're having to deal with the balance, whereas on the last circuit you just put plus C.
Because you're taking one backwards, what would be the absolute value of this?
Absolute value, it's natural log of the absolute value of x, yes.
Yeah.
And then you still need to do from whatever to whatever.
asked about change of
Oh, no, it stays +1.
Did you get the negative release Oh, wait, I got it. I forgot what it was.
Someone makes sense, I just accept it.
Don't forget that you should be trying to check your integration by doing the derivative before you keep going. Always check your antiderivative by taking the derivative.
Mr. Townsend, secant squared, is that weird one where it's like tangent +1 or something?
The derivative of tangent is secant squared.
What's the derivative of secant squared?
Why do you need to know the derivative of secant squared?
I think it's what I'm trying to do here, right?
I thought you were trying to do the antiderivative of secant squared.
I'm trying to do the anti.
So what can you take the derivative of to get secant squared?
Oh, tangent.
Well, it was originally he had to get his ear.
That's one that we have memorized.
Dad said no. So then we came up with something else for him. Yeah, honestly, that's not even a bad punishment. That's what we chose there, is because of the fact that he tried to get out of it, then we made it actually punishment.
Some good questions on that. Natural log. Now, the distinction of plugging in or positive doesn't matter, but I would still write it down how they have it.
Okay.
So square root of 2 over square root of 3. So it's negative check the side.
But if you don't remember that one, you should probably write it on the top of your paper. Review it again. Alright, you guys have one more stuff on that? That one actually has a little bit of trick to that. You remember in pre-calculus there was a sine squared plus cosine squared is equal to something?
Oh, I don't remember those. It's been so long.
You can just change that to a 1. And then integrate so that.
That's one.
Okay, I get it.
It's the square root of 2 over 2 divided by the square root of 2 over 2, which is natural log.
I don't even use those. 45, 45, so both sides are the same. It's always going to be one.
You're saying think of what power station is supposed to
So 1 is a weird what power is 0?
No, because if I did yours, first bring the power down, lower the power by 1. that would give me cosine squared. Then you could have cosine in there too.
Because if it was
And that
cosine.
has lots of cosines. So that doesn't
Yeah, so I thought it was, since she was trying to work with that, that's gonna be like, this is now. It's like, if this was halfway through.
So you get raised
Oh,
out.
cosine
So
squared,
it's.
then you square, and then, so then you do all this, and then you chain roll, and you go by 2. So when you multiply by 2.
You get it for free.
It would get that
So this one, it's making cosine. Oh, you have to do something.
You can write down what you think.
Would it just be cosine plus sine?
All of that is just different processes, right?
What, just, is that what I'm trying to find?
Because root of sine squared.
That was pretty good.
So putting in negative cosine squared plus sine squared.
And if it's
Well, it would be,
Part of why that's.
it would be 2 sine. It would just be 2 sine. 2 cosine.
Derivative of sine squared.
I think so. Wait, so you're like,
No, it'd be, wait, is it derivative of sine squared?
yeah.
Two sine squared. Or no, sorry. Like chain rule,
Times cosine. Two sine times cosine. I think that's right.
Well, that is complicated. When you look at the answer, it's usually what make the most sense.
It's gonna work out the same, but you don't have the limit problem.
Well, we have to get this right, and we have to plug stuff in. So it's, we're not gonna be able to use that.
0 plus 0, it's just.
I don't know, when you look at the derivative, what you're looking at, you're looking at. Yep. Okay, but the good news is we don't need to know for that question.
Cosine is 0.
No, but I was thinking.
It starts at 3 pi over 4 and the zero. So when the upper bound and the lower bound are the same, there's no area to be had.
So it'd be 1 plus 1 is 2. Oh, it's 1, okay. It's not the last one, it's the last one. Squared.
I played in the snow, so that was great.
Mr. Townsend, what would the antiderivative of change in square be? Is that something you're sure?
The derivative of secant is.
Should we just put 1 over tangent squared? Is that right?
No. You can't do that column by side.
There's no double score.
Okay, so remember integration usually the only representation you have at this point is area under a curve.
Probably the most likely.
So how much area is there from 3 pi over 4
I think
to 3 pi over 4? There you go. If the lower bound and the upper bound are the same, then there's no area.
Okay, so it's 0.
So they gave you one that you can't integrate.
No,
so you couldn't
you're
do
like
it.
that.
Anytime your lower bound and upper bound are the same, there's no area.
Okay, so it's a trick question.
Not a trick question.
Because it makes you look at
Because it's always
at
just
first,
like
that's my
getting.
question. I just thought looking at that until the very end.
Yeah, so this,
I feel so.
yeah, so this is really hard to integrate because you have to worry about integral a lot. But
I
because
think
of
about like
this, you can change up to 1. And then
like, well, I mean, I was on 5 a.m. today.
1 doesn't integrate to 1. The derivative of 1 is not 1.
Wait, it's 4.
I just like.
Changing all of this stuff to 1, but I haven't done the calculation. Okay, so x, but in this case, not x.
And they're related.
U from 3 to -7. So, 1/10. But basically, you know that one, so you might write down top of your table. Okay, so yeah, these are pretty hard to anti-derive because they create some chain-rule problems. But they expect you to remember this first Pythagorean identity. Sine squared plus cosine squared is always 1. So you can just change all that mess to 1 and then integrate.
Just get there too.
And if you don't remember that, you probably wrote it on the top of your head. So you do expect you to know that. Yeah.
A squared plus a squared minus
Well, the only way you can make it is to recognize that this is
Just about
Oh, it's A. Yeah.
You in this, or, I was thinking just put X just to No, but like, which letter? Okay, so it is -1. Okay.
No. Absolute value only. So delete this, then delete the +2. And then go over 1. And then +2. Straight. I can read what's on.
Yeah.
30, that's on the front page. Oh, there it is. So we have to read the whole. Wherever that's. Oh, that's on the last page too. So now we have to move one another. Intimately.
What that is.
Will you, like, will there be calculator questions on one test? Or are you gonna make us learn how to do this one, right? Oh, great.
So who gave you all the calculator? You have to do all of them. Smart calculator. The calculator has on it. There's really nice by here, but you also take your time. You have a calculator, but you
Very much made a mistake in this problem. I don't know why.
Okay, so let's test by doing the derivative. What's the derivative of cosine?
What did you do?
Oh, it'd be negative. So put a negative there and then it'll be okay. Yeah, always, as soon as you do an antiderivative, just immediately take the derivative and make sure it's what you need. Because otherwise you might do a bunch of work, you just have to erase it. What can you take the derivatives of to get tangent?
So it's three.
It's good that you're straight line because the thing is you can't do that by even. There's nothing we memorize that has a derivative of tangent squared. It sounds like
Technically, this is saying 3 times.
it doesn't matter though, because think of it as area. How much area is there going to be from 3 pi over 4 to 3 pi over 4? Right. If the lower bound and the upper bound are the same, it's not opening up to create any area. So that's one of those properties that we don't really need to memorize. That's not good.
Well, it kind of is.
If you frame it in your head as an area under a curve, there's going to be zero because it's not open yet. That's all we have to know. I mean, you will definitely see that type of question in the future. That's an important property.
Okay, so I know this one's gonna be 3 minus 3, but you got square.
No. That's not the antiderivative question. So like if I just look at this part, I would do power rule, bring the power down, lower the power by 1. So that would be 2 sin x times the derivative of the So the derivative of this is 2 sin x cosine x, which is
Natural log of the square. So what to the power of the square?
you can't do that
What
one
power?
without doing chain rule, which we are trying to avoid. But you could do this substitution. They expect you to know the first Pythagorean division 1, and then integrate 1. And you know the
So 2 minus 2.
So say that you have to find and evaluate.
I got 2.
But you should write that down on top of your paper if you forgot it. That's one of the few things to freak out.
Oh,
Well, what can you think of
this is just
the tangent square?
or natural log over 2.
That's not the derivative. It's equal to that. I guess you only change tangent squared and squared minus 1, but you still haven't integrated it.
When my calculator froze, I was kind of like, just didn't answer it for some reason.
Yeah, I just kept pushing
I was
the
like,
button.
and then it answered.
It sounds like.
I just kept pushing enter. It just was not. I didn't do anything.
You should not know how to do that. Except. I remember integration of the area under curve.
It wasn't exactly 13. I was thinking, is that like supposed to be on the square the high one?
I think it's one of the ones where it messes up.
Upper bound and lower bound are the same. If you plug in the upper bound, get some number, and then you plug in the same lower bound, you get some number, and subtract them, of course it's going to get upper bound and lower bound are the same, those are but just think of it as area under curve. If they're the same, it has no room to open up. So
Because I know for a fact, like,
that would be 1 over 2.
is it true?
Why don't you just take the derivative? You can take this number out front and get later. So it goes on 1/2. Now when I take the derivative of this, I get 1/2 times 1 over u. 1/2 times 1 over u is that.
Wait.
Hey, you guys are done under 30 minutes.
Positive 1 plus.
Again, I really think we can get this done in class. It's not homework. It's not a last page. We should have
There's
this
not the
question.
rest of it.
What can you take the We don't memorize that. It sounds like one that we memorize, but it's not one. It doesn't matter. Right now, the only real thing that has penetration is area. How much area is really we want to start off at 3.4 and end at 3.4?
So basically like.
It's not, there's no base
All this morning here, and I thought it was.
Or you can
It's
take
like
it
negative. So I just feel like
and you plug in
X
the
is equal to X.
and then you plug in the lower bound.
And then it's 0 and 4. And then it's negative
The lower bound and
X.
upper bound are.
Like the absolute value of X is equal to negative X.
I think
And
it's
it's between negative 4.
I take shower.
It's like negative.
Completely forgot how to do polynomial calculator.
Alpha window, or probably need to write the step down on your. And then actually.
Something like that. Take the bounds, take both these functions and like unbound them. From 0 to 4, is X. Go from negative 4
Well, that's
to
the
0,
sum.
it's negative X.
What that's supposed to be, you know? You know how we have to draw that negative
Kind of the right thing.
It's just
But integration is the way.
We're getting
Yeah. And that's basically what it's
that looks like the ambition.
16. Be 16. Should be 16.
I don't do public. So which one?
Okay, what tells you right here? I think it's a different, three in it, so maybe that's natural love factor.
Natural law.
Actually, you can think of it in three ways. That,
Oh, you just read it.
1/2 X squared, you just think about it. Like it's just, it's the same regardless, so you can just add. So,
It's the
I think guys are starting to see that none of these questions are all that terribly difficult, but there's a lot of little things to consider. That's why it's getting tough for people at first.
Well, it was either at natural log or square, and that just
What? I didn't hear the whole thing, I would know.
If you have the natural log e squared, and then this 2 times the natural log this is 1 times 2. Natural log
So, if you're looking at my work, you're not gonna understand. It's not broken out. That's all.
Nope.
This over here is gonna be.
yeah, all class.
But,
Yeah.
is it just?
I mean, it is.
Where? Oh, wait, where the tangent?
Okay, that's what. So these cancel out, the a squared minus these cancel out. Oh, actually, it is. So,
And then you integrate. And then you integrate it to get secant third x.
That's the one you're on too. I don't know what the picture is of your tangent square.
Like, don't you have to do that?
It's telling us that we were making questions, we have to.
Secant tangent.
It's half you. That's what.
It's good that you're hesitating there because this doesn't match any of them. It just sounds like one. I don't know what the antiderivative is. It doesn't matter on that question because you can frame it the only way that you know how right now. Is area under a curve. How much area is there from 3 pi to 3 quarters? There you go. Because it's not opening up at all, right?
It's just saying you're plugging the same thing.
Yeah, or if you imagine at the end, if you plugged in that and then you plugged in the same thing and you subtract the proportion. Yeah.
I didn't really.
No, that's an important part. You'll see that as a yeah, behind you. But instead of just telling you the property and how to realize it, like it's a good reason you don't want it. You have enough money.
I wrote it down too, and I'm like,
The little upload, just it either takes 2 seconds, or like 3 minutes to make a picture.
Well, if the negative or you're going from 0 to 5, you're going from 5 to 0, you're in other directions.
In my luck, it'd be like 2 seconds.
It's like slow. If you do right, it doesn't run for slow.
Okay, so.
Your run has to be left to right. If you do right to left, it's actually, you gotta do the negative.
So this is 2 plus. 2 plus 2 minus 6. See how this matches up? This matches up here, but it's times 2. Minus 6. Because it's plus, but.
I think it is something with natural log, if there's either
the only way to get it is math.
So it has to be actual log.
Like push math.
What if this natural log
is not
Wait, because then you do the natural log of u times 1/2, which would be 1 over 2u, right? Yes.
The only way you can do it by hand is because the thing is to know how to graph this.
The natural log would then be 2 over u, because if you want to
Recognize this as a circle.
You go 2 plus
so then
7.
it might be 2 over u, and then we multiply that
You know what the absolute value of that graph looks like?
derivative.
You could
2
graph it out.
that would be
But this is plus.
0,
Which way you
triangle,
can do it. You're right, you're right. Because if you have 4, you could do it.
Well, because it would be 1 over, well, first it would just be 1 over u, right? And then we have this, so you multiply 1 over u by 1/2.
Look at that.
And that just puts the 2 on the bottom.
I did, because it would be 2 of them.
This is a plus. Absolutely.
If you have,
So now, just like with derivatives,
Yeah.
there's a constant out front, you just kind of pull it out and worry about it later. So I would suggest pulling the 1/2 out, multiply your amount.
Okay, is the next one?
Because you need absolute value sign. And you need the right to show that you're not evaluating for one third. You can't say that there's. So 1 over u becomes what? And like absolute value.
It's 2a.
What is the absolute value?
How do you derivative of all?
It's
Is
absolute
that the derivative of
natural.
This 2 is just gonna make it twice as big. So it's
No,
gonna be
no, I'm already past that. I'm at 2 minus 6. But I can ask.
2 minus 6 is -4.
Yeah, yeah, but are we supposed to anti-derivative or something? Or is that the explanation?
Well, this 2 two that you got here, so they already did the answer.
Oh, they already did 4, so this was.
Well, I don't know if that's the answer.
They did the answer.
Oh, is it 13?
Number second?
Yeah, that's 13.
Obviously, there's a couple things on here you might not have thought of or were not intuitive. I really suggest you write those on the top of your papers so you can go in with the paper. All of these questions are good questions. None of them are crazy tricky or anything. They might seem tricky to you now, but
Oh, yeah. Actually not very nice.
This one, I put it in my calculator and 14, anywhere around it, it doesn't match anything.
yeah, you gotta pay back the recalculate again. We did this one together.
Yeah.
You already did that.
I'll help you with it. I think you need to pay attention to those. There's a reason I'm going over some of them with you. Okay, so I don't know why they did this, go ahead and hit enter. But what they did is they took their answer and they left it in terms of pi. So the answer times pi, there's some number times pi that's giving you that. So to figure out what it is, divide by pi. And so your answer should be 4.5 pi. That's what it is. Again, I don't know why they did it that way. Okay, well, there's a constant with 1/2. Just like with derivatives, you can kind of like pull it out front. Natural log after the value of u. So you integrate 1 over x. Natural log from that to that.
Yeah, thank you.
That would be evaluated from 1 to
You have to subtract.
Are you done? You have to put the bracket there.
So, think about the curve, or like, think about a line.
So then plug in the bit. Where is it?
Well, that's exponential important,
We can do that by hand.
16.
so one of these is from 0 to 5.
What's the natural log of e to the bit?
So this whole thing is 2. But one of these is just from 1. So it's in that triangle or that curve. But it doesn't
Natural log of e to the bit. Come down.
Wait, no, okay, so it'd be minus 8 again.
So minus, so negative 2. I saw that on the other side.
Oh, yeah.
Wait, what number was that? I stopped.
There's negative 2.
Well, that's our
What the extra here?
Following question. Remaining question. I forgot.
That's what I did. Oh, well, yes. No, I don't know.
Wait, so if f is 2, it's just 2, right? In that variance?
Yeah, but I don't think
Yeah, because if it doesn't, then it's just all the power answer just gonna be given to the one.
It might be a different type of question. Oh, there's an 8 here. -4 is an answer.
So for a,
The second page.
17.
Plug in two, the first one here, and you put two here. Wait, three, maybe three here. Six. So 2 minus 6. 2 minus 6. I don't know if it's right.
No, because we're not using the 5 and 0. Like, if they have that there. Or everyone. No, okay, but if you look at this, if you look at it like this, you have it like this. What if we have, so if you, what if it's -4, you would have 0 to 5. There's no x to plug in, so it's just -4. There's no x to plug in, plus 4. I'll go with 0. Because it's like if we don't have an x in it, every single time it's going to 0.
But it's 2. Oh wait, it's 2. What's L in 2?
I think we do that.
Wait, didn't you put the other one in?
Well, there is an answer of -4.
That's what's making it. I mean, hold on.
If there wasn't an answer, I would think it was random.
So we literally have 3 left. So obviously not. We have -5
so
I'm thinking maybe the.
all this.
I think it should.
Where it's 2
And then,
minus
Yeah,
6.
you're right. So those are already like 0 to 5. So that 0 to 5 is 2. That 0 to 5 is -3.
Oh, wait.
-3 is number 2.
well, we're supposed to use these in all the rest of the questions.
This
That's what it
is
says.
2, but they've done the antiderivative for you. That is 3.
They flipped the 0 and the 5. Why did they flip the 0?
Okay, so antiderivative 3 would be
And that's asking what derived gets to 3.
What is that?
0 to 5. 3 would be. What is it? Okay, it can't just be 3 then. We already have an answer. 0.
Dude.
So it's 2 plus 3 plus 15.
Oh, that's it. No, that's easy. G of X is.
You don't have a question?
I think we got the G of X is
7 more questions.
But we still got to.
What would fx and E of x mean?
So would this just be -4?
I don't know. The area from 0 to 5 of f of x is 2. And then 2 times that would be -6. They're just making you like piece them together. They're not trying to get you to practice integration. They just want you to see how to piece them. Sometimes it'll be like integrating from 0 to 1 is 1, and integrating from 1 to 5 is 7. So how much would be 0 to 5? And you have to realize that. Again, I think phrasing it as area under a curve gives you like some kind of visual.
This one is 5 to 1. There's 3 Oh, it's 0 to 1. 0 to 1 of f. It's 0 to 1 of f of x is 7. And then 1 to 0 to 5 is 2. Okay. So.
3L and 2x?
And the 5 I was thinking so 1/2 is one over 2. So and then that one's going to be divided by 2. So 2 is minus.
We'll have about 10 minutes. If you don't finish in 10 minutes, I need you to finish up your homework. If you think that you need some help with it, you need to sign up to come see me tomorrow or Wednesday during prime time.
It's too good. I'm just like a calculator.
The x squared over good.
Return to that.
Wait, so you just have to
Yeah, they've already done it for you. They just want you to still have this speech in the other. I don't know if they can work for you. Give you double that one.
No one show where you messed up. What we did mess up is all these right after the year.
And the next one is the same. Oh, also we're
Well, we already had it.
What's your new phone? I'm kind of in the market for a new phone. I just don't want to spend the money. They integrate 3, you get 3. They integrated the first 2 for you, but the last one you still didn't integrate.
Plus 3x. Plug in 5. We get 5 plus 15, which is 10. Oh, and then you get the
So, you got that from the other page? You got that from the other page? These 2 were integrated for you. Yeah, you didn't. You still have to integrate 3 or yes.
So if I'm putting this and fix it to minus you guys, that's 3, that's 5 total. Then we have 3x. Plug in 5, you get 15, what's that, 20? You get 20. Minus 3. But what do you want minus that? No, that's, those 2 are already separate. This is just for the 3. Oh, I get it. Yeah. Those have already been answered. Oh, yeah. As 2 and 3. Turn all this up. That's true. 73.
Okay, you guys are down to 6 minutes. I'm gonna say one more time, make sure you know what you need to turn in your classroom before last Wednesday. When you come finishing this, I would be happy to help you Tuesday during advisory or Wednesday during advisory, so you need to find yourself up on the timeline that sounds like you need some help.